Oh, hi there, individual. Welcome to Randomly Typed. My name is Lance.
And I'm JS.
Hi, JS.
Hi, Lance.
What are we going to be talking about today?
I chose a subject that I really like. Well, I could say I really dislike, in fact. DRMs.
DRM? Okay, yeah. Digital rights management, for those not in the know.
Congrats, that was my first question. All right, so if you were to define DRMs, like more than just the name, what would it be?
DRM is a set of technology. I'm making this up as I go, by the way. It's a set of technologies that attempt to restrict usage of software products to their intended usage.
Really good, but I would just change one thing. It's not necessarily software. It's just copyrighted work. So like audio, video, that are not necessarily software.
I guess it does need to be distributed digitally, though.
Yes,
right? Like
absolutely.
You can't DRM a book,
Well,
like the
yes.
physical book. Right?
Yeah, sure. Let's just go with copyrighted work.
Okay,
That's digital.
fair.
So let's go for some historical example that we'll all know. DVDs. By default, you cannot clone a DVD. Like you can put it in your DVD player, you can watch it, but you shouldn't be able to just clone it and make a copy.
Really? There's so much software back in the days on Windows that would let you just... I mean, I guess they exploited.
Yeah, exactly. They just cracked the DRM. So the DRM was called CSS for Content Scramble System. DVDs were first introduced in 1996 and they were first cracked in 1999. So it took only 3 years to crack it.
That's an adequate amount of time, maybe? Yeah.
Pretty quick.
Do you know how that works? The content scrambling?
Every software or hardware that's reading the DVD needs to get a license from the DVD people, and this gives them a key to be able to decrypt the content of the DVD.
Okay, makes sense.
I guess they just extracted keys from software and hardware to be able to just crack it.
Okay, that seems like a pretty simple fix, right?
Yeah.
Just like extract the key from some hardware device.
Yeah, the idea is simple, but it's pretty much always the same problem. It's like there's a key somewhere, and can you get it or not?
Even still today?
Yes, but it's way more convoluted.
Okay.
So today, it's like, how do they protect video streaming, right?
Right.
So that will be the last subject. At the end,
Okay.
we'll be talking more like technical. Before, it's more historical, cool trivia.
Cool. I didn't mean to skip ahead.
Oh, it's cool. See, I just prevented you.
Perfect.
All right. Other nice examples are games. They often use DRMs to prevent you from just cloning the game. Let's talk PlayStation 1. That was actually a really nice one. So do you know, Lance, how a CD works?
It is a physical media which has bits encoded into it through some mechanism which has to do with light.
So just imagine a vinyl disc which has a groove, which is a big spiral that starts from the center to the end of the disc. So it's exactly the same thing, but rather than a groove, well, it's still a groove, but really much smaller. And you can just read it with light. So when the light reflects, you get 1. And if the light doesn't reflect, you get 0.
Oh, I didn't know it was that simple.
Yeah, pretty simple. Though, just like vinyl, they're not perfect. There's always some wobbling when you read it and in the groove itself. How did PlayStation secure their disc? Because you couldn't just take a PlayStation game and clone it and it wouldn't work. How would they detect the difference? Because it's the same bytes, right? So they were encoding secret data in the wobbling.
What?
Yeah. So normal CD readers would just ignore the wobbling because their job would be to stabilize the disc and ignore the errors. PlayStation, well, Sony, encoded data of like in which country is this playable and things like that in the error at the beginning of the disc.
Wow, that's so. I guess like, let me know if I'm understanding this right. They kind of like exploited the analog nature of discs in the like error rate between a 1 and a 0 to detect whether something was playable or not.
Yeah, imagine the groove being a perfect spiral, but it's not perfect. So it goes a little bit too much to the right, a little bit too much to the left, a little bit too much to the right. They encoded their information in that.
Wow, that's mind-blowing, actually.
Yeah, that's how PlayStation did it. There's also some more low-tech solution, but that's really interesting. Game Dev Tycoon, do you know about this game?
No, I don't know about this.
It's like a game about having a company making video games.
Very meta.
Yeah. So they released two versions at the same time. They released the real version like on Steam and one on torrent site. And in the torrent version, you'd always lose the game because people were pirating your game.
The ultimate trolls.
Exactly. So it's not a real protection, but I guess they trolled a lot of people like that.
Yeah. Ah, cool. I have a question, actually. I guess we're talking about like hiding information in digital media. In all of the Blizzard games, the Battle.net games, at least initially, you'd have like your own Battle.net key, which is just like a physical way to authenticate that you're the only one that has this key. Does this fall under DRM or as well? Because I mean, it's not the only thing that you're missing is like the digital key, and it's given to you. It's just that it prevents piracy because you can't have two keys registered more than once.
I'm pretty sure we can call this DRM because I don't think DRM needs to be fancy. It's just a digital mean of restricting how your thing is used.
Yeah, okay.
So I would call it a DRM.
Yeah. Even if it's like physically printed onto.
Yeah, well, but it's still a digital mean of preventing you of using it.
And they do keep track of it digitally.
Exactly, because you need to log into your web account.
Yeah.
So I would say yes. It's I would call it a DRM.
Cool.
Though I'm not a lawyer, so, same advice as every time. Don't quote us.
Yeah, neither am I.
So now, problematics. The idea of DRMs are interesting. Like, you protect a media you created for people so people don't pirate what you did. But it's not that simple. It's not that nice. Because it prevents you from using the media you bought in some legal ways. For example, you have the legal right of making backups of your things and lending it to a friend. But now, with digital games, most likely you cannot do that. You cannot back up it. You cannot tell your friend, hey, take my game and play with it and give it back to me in 1 week. You cannot do that anymore. Their DRM is preventing you from using the thing you bought in a legal way.
I guess they're incapacitating the digital version. If there was a physical version of this, you would be able to, but...
Well, not necessarily. For your example, with the Blizzard game, you couldn't. Your friend would need to log into your account, which has other problems.
Right. But I mean, if Blizzard made board games, like you could lend it to your friend, right? I guess it's just that you're buying something else, right?
But it's still, you have the right, the digital thing you buy have comparable...
Like restrictions or laws placed on them?
Exactly.
Okay, I wasn't aware of that. I mean, if that wasn't the case, you could argue that, like, well, you bought this digital thing. It's just different, right? It doesn't work like it does in the real world.
Yeah, but there's still some laws that protects you.
Okay.
Another problem, DRM that stopped working. For example, if the DRM relies on a server, just like your Blizzard example, what if the server stopped working?
Right, if they go out of business.
Yeah, now what you bought doesn't work anymore. And there's many examples of that. For example, MSN Music and Yahoo Music Store closed in 2008. So now all the thing you bought doesn't work anymore. That's a problem.
I would say, like, maybe this is one of the impeti. I'm not sure how to say that word in plural form. But for all of these subscription-based things.
But they're not subscription. That's the thing. It's like they bought the CD in the digital form. Right. It's not a subscription.
But that's kind of what I'm saying, in that, like, maybe companies are kind of sidestepping this problem altogether by declaring that their services are now subscriptions, right? They're like they're not giving you the right to the thing.
Yeah, but not because they're saying it that they're allowed to say it and that it's legally binding.
Right, absolutely, yeah. And I mean, they're most likely in the wrong, all of these people who like sold these things that can't provide it anymore, because I guess they sold them as a digital good.
Exactly.
Whereas I guess most things I see now have pivoted. Like there are very few things that you can buy that are actually yours on the internet now.
Yeah.
So I guess it's just like a struggle of the market that is giving DRM digital goods to people.
Yeah, they don't want to give us the permission of using it long term. For example, Microsoft this year closed their ebook shop and all the DRMs stopped working.
Right, I heard of that.
Though they refunded everyone, so that's cool, but still, you bought something that for no reason stopped working.
Right. And like, you still, like, even with a refund.
Yeah. And in the same vein of ideas, like conserving media, there's some museum that won't be able to conserve games from today because they are all under DRMs. This is problematic because in 20 years, this will legit not exist anymore.
Right. I guess the emulators work to keep those things alive.
Not all the time. For example, if your game is an online game,
Yeah.
and what if the server doesn't exist anymore?
Yeah, absolutely.
You don't have a game anymore.
Yeah.
Fun story. Well, fun. Here I use a air quote, as always. In 2005, there was a scandal with Sony that was bundling viruses in their CDs. By viruses, I mean a rootkit that was hiding in your PC to prevent you from using your PC as you would intend. So like it was preventing you from ripping disk and things like that.
Whoa.
And
Nuts.
and the software was pretty bad. So it was introducing vulnerabilities that other viruses were exploiting to gain control of the rootkit and things like that.
Excellent.
It was
Amazing.
crashing computer. There was no uninstaller. My favorite part is that they were using some open source software without writing it in the license. So they were infringing copyrighted work from other people.
Yeah, triple whammy.
Yeah. They wanted to protect their copyrighted work by infringing other people. So they got sued a lot in the US, but
Yeah. Subsequently. Yeah.
but still, it's not a ton of money. So they settled, like I think in total it was $1.5 million for like pirating charge, which is not a lot.
No.
Some people get like life sentence, and like the worst thing you can get for way less than pirating thousands and tens of thousands of computers.
Absolutely. For a company that size as well. Too,
Exactly.
right?
Honestly, I don't understand why they're not all in prison, but hey, I'm not the judge here.
The judge of JS land, you are.
Oh man, there will be no DRM in my land.
Yeah. It'd be a dictatorship.
Maybe. So now let's go in the modern world. As I mentioned a little bit earlier, games that have a server can be problematic or different. So for example, Google Stadia, that's a weird one because you don't have anything on your computer. You just have a stream. Honestly, I feel that Google Stadia and things like that are like the next level of DRMs.
Well, again, like, is that DRM or just subscription? Are you willingly... I mean, I guess it suffers from a lot of the same problems, but it's like...
But it's DRM as in it's a technology that protects copyrighted work.
It prevents you from... I guess the difference is that, yeah, the purpose is that you never owned it to begin with, right?
But you buy games on Stadia. That's the thing.
Right.
It's like full price $80 games
Right, okay, yeah.
plus the subscription. So don't tell me I didn't buy the game.
Well, I mean, I guess legally you probably did not buy the game, right?
Yeah, I know. But it's always loopholes and contract and
Right, exactly.
shenanigans.
So I guess, like, as a consumer, you should either boycott these companies or give in to the fact that you do not own games in this day and age.
I'm not necessarily saying boycotting, but it's just a new level of DRMs.
Yeah, when literally the game, the computer, everything about this game, except for the pixels being pushed to you, are not yours. I would say that's a subscription, right?
Except when you pay full price.
Yeah.
But this is only working for interactive media. Because for like video and audio, it doesn't really make sense. Because if it reached your computer, at some point you should be able to clone
have it, right? Yeah.
This is called the analog loophole.
Oh, cool.
Yeah.
I like it.
It's like whatever you're doing, at some point, non-interactive media needs to be transformed into analog. So you should be able to rip it at that point.
But not unless it counts on analog inputs, though. Could you repeat that?
If you have any media, non-interactive media, at some point it will need to be transformed into analog signal for me as a human being able to consume it.
Okay, sorry, I missed that part. If you have interactive, though, that's a whole different thing, right?
Absolutely. It's not as simple.
Because it would likely rely on either some third-party thing or...
Well, the thing with the interactive media is that it's not like it's just a single stream. Like it's a input-output reaction.
Yeah, like a loop, yeah.
Exactly. Doesn't really make sense here.
I guess for it to make sense, you would need to gain access to literally the control loop that controls what output comes following whatever input you gave, right?
So you need the game.
You need the game, right?
All right, next. HDCP. Do you know this abbreviation?
This is a networking thing.
No.
DHCP, that's a networking thing.
Yes, it's not that.
Too many acronyms.
Yeah, all right. It stands for High Bandwidth Digital Content Production.
Okay.
So that's the thing your monitor needs to have to be able to play HD content on Netflix.
Are you serious?
Oh, yeah.
So, but is it hardware or is it a certification?
Both. The company that sells you your monitor needs to get the license to receive the keys. So now when you connect your monitor to your computer, for watching encrypted content, there's a handshake that makes sure that the content on the wire, so HDMI or DisplayPort, is encrypted.
How have I never heard of this before?
Well, it's everywhere.
I guess like I've also never made my own monitor, so
This,
probably
but
why.
often when you buy a monitor, it's written which level of
Okay, so there are
things they have.
multiple levels.
Yeah, well, version. So the last version is HDCP 2.2. So that's the one you'll normally see, and that's the one you need to be able to watch 4K content.
Okay, so if my monitor has it, then you can watch 4K content.
No, that's just a small part of it. That means that your monitor can receive the 4K signal and display it, but also afterward you need that your computer can receive that signal and is able to send it. We'll go there next. There's so many steps. So this is just to block the digital loophole. Like the last step needs to be encrypted and be only played on a certified device. For example, if Sony has a license, well, for sure they won't make a device that would let you rip it.
Right, so I guess this closes the physical loophole, like in
Yes.
that you need this specific piece of hardware to even begin thinking about cracking this DRM, I guess.
Exactly. For example, Blu-rays have that. If you're watching a Blu-ray without the HCP, you'll get a lesser version of what you bought.
You mean HDCP?
Oh shit.
That's the
Yes.
networking thing.
So Blu-ray will downsize your video stream that you bought on a disc.
So like the Blu-ray reader.
Yes.
Yeah. Wow.
So you'll get a shitty video because you didn't buy a monitor that's certified.
Wow.
That's sad.
It is sad.
So you bought the content, but no.
Right. That's the thing. Like you own it, right? But only on like their terms.
Exactly.
So like you have the bits.
Well, you have the scrambled bits. Now, if you want to unscramble them, you need to have all the monitors and all the material.
Yeah, abide by their rules, I guess.
Yeah.
Crazy.
All right. So now the last interesting technical part. Let's talk about EME. EME stands for Encrypted Media Extension, which is...
Isn't this the browser's stuff?
Yeah, it's a specification from...
Right, it's the browser specification for this.
Yeah, from W3C that was released in 2017. So it's just an API description to let company build DRM software that can interact with the browser.
Right, so they can deliver it to the browser, I guess?
Yes. So previously, when you were watching Netflix, you needed to have Silverlight. So
Yes.
a third-party plugin.
Which was a huge pain on Linux.
Oh, yeah.
Not anymore, though.
To be able to like decrypt it and play it. But so now what EME is doing is like it's doing a standard API for the company to implement their DRM stuff. Google has Widevine. You'll see that on Android, Google, Chrome, Chromebooks, and others. Firefox also. Microsoft has PlayReady, which is used for Edge and Friends. And Apple has FairPlay, which is used for iPhones and Macs.
So from this, I gather that like the specification is like an API specification, and then the implementation comes from, is it like third parties? Does Firefox have an implementation of this?
They're using the binary blob that Google gives them.
Okay, so yeah, it's not something that's open, right? It's literally just the API and everything else is...
So that's one of the problem for this episode, is that all the content I wanted to know about was under NDAs. All the spec of Widevine, PlayReady, and FairPlay, and all those things, I could not find them.
Crazy how I guess Firefox is including these binary blobs.
Yeah, well, that was a hard thing to do for them because I know at the beginning they were not doing it, and on Linux I had to like boot Chrome to be able to watch Netflix.
Right, but I mean everybody wants to watch Netflix, right? So I guess they were losing market share if they didn't.
Exactly.
Huh.
And when the W3C released the EME spec in 2017, the same day the EFF resigned from W3C.
Oh.
Yeah, they were like, nah, we cannot do that.
I'm getting out of here, yeah.
It's kind of sad, but they needed to do it.
I absolutely understand the reason for doing so.
Yeah.
So I guess these binary blobs are made to interact with specifically streams like Netflix and stuff?
All right, that's the next step.
Okay.
So, exactly. There's two parts. There's the provider, Netflix, that has content that needs to be encrypted and sent to us. And there's our part on our computer that needs to be able to decrypt it. Let's play a game. How should we not implement Widevine or some EME extension?
How should we not implement it? I'm not sure I understand the question.
Okay, let's say you're writing a browser and you want to do it. A browser is in user space, right? How you would do it? You would do a handshake with Netflix and you would say, those are the keys to decrypt the content. And you're good. Now you receive the encrypted content, you decrypt it, you send it to the kernel sends it to your graphic cards to your monitor. You see it. What's the problem here?
Long silence.
So there's many problems here. You receive the key in userland, so you could just rip it and open any stream and rip them.
I mean, unless it was like a one-time password thing.
But still, since you have the key, you could be able to decrypt the stream and put it on a DVD or whatever.
That one stream.
Yeah. But still, because their goal is to never be able to decrypt the stream. So providers are unhappy and you don't get HD. That's how it works. Afterward, let's say now that you can put some of your code in the kernel. Would it change something?
I mean, probably not, right? If you had your key like in memory, you can still get it.
Right, because you can sudo and code dump anything from your kernel. So here, the way it would be done, it would be, let's say you tell the kernel, go do a handshake with Netflix. And once it has the key, the browser asks for the stream. When it receives the encrypted stream, it sends it to the kernel decrypts it, puts it on the graphic card to the monitor. But again, you have the control of your kernel. Same problem.
Yep.
You don't get HD.
I'm with you so far.
All right. At that point, Lance, what's the next recourse? If you cannot trust your own kernel,
well, I mean, as a developer of the spec, I guess hardware, right? Is it like some kind of ROM that's shipped to you?
Kind of. In all modern computers, you have trusted environments to run trusted applications.
Okay.
Those software are run somewhere that you don't have access to the memory and CPU and anything. So it's another CPU.
Right. Damn.
Yeah. Now that you know that you have that, how would you do it?
You've lost me already.
All right. I'll give you the answer.
I'm not really a hardware guy. So how would you implement that, JS?
All right. Let's say when your hardware gets a certification when it's made, you bake a key in it. It's a secret key. We trust that the hardware is good enough that we cannot extract the key. This trusted platform does a handshake with Netflix to get the key, let's call it key B, from Netflix that will be used to decrypt the stream. So now it has a key to be able to get the stream. Now the browser asks for the stream, let's call it C, pass it down to the kernel down to trusted environment decrypts it, puts it in one of its buffer, puts it on the graphic card, puts it on a monitor. But there's a small problem here. The kernel owns the graphic card. Does it mean you need to share a buffer with the kernel? How do you do it? Does it mean that the graphic card needs to be owned by the trusted platform or trusted environment?
Enlighten me.
I don't know. Everything is under NDA. It's a legit question. Yeah. I don't know.
I was also thinking that, I mean, I'm sure they've outsmarted me in my extremely poor attempt. But like if you proxied your traffic to whatever Netflix is trying to do a handshake with your trusted module. Mm-hmm. But I mean, I assume they're using some kind of something like a Diffie-Hellman or something.
Yeah,
right?
Exactly. So you can see the traffic. The traffic goes through user space. But since it's encrypted, then only your trusted environment has the keys.
And I assume they would share and validate keys only
exactly.
after that connection is established. Right?
At the beginning, I mentioned that you might have a key baked in your trusted environment, like hardware level. This key is used to authenticate that it's the real,
is legit, right?
And they do some fancy handshake to be sure that Diffie-Hellman and things like that. Yeah, honestly, I was looking for information and I was not able to know how they close the gap at the end.
Not a lawyer, but it should be legal to reverse engineer this if you were able to, right?
No, it's not.
It's not?
You could go to prison for that.
How?
Because everything that's under...
It's your hardware, is it not?
Yes, but no. The same thing, even if you buy a car and doing reverse engineering on a car, you could go to prison. Even if you own it, reverse engineering it is protected by some whatever laws in the US, and it could be really bad.
Huh. I was always under the assumption that you were able to, unless it was like at a cost of not necessarily yourself, right?
No, because all the researcher, like security researcher, are in a gray zone. Because most of the time, what they're doing is not technically legal.
Huh. It's good I prefaced that with I'm not a lawyer.
Yeah. That's what I had for today.
Awesome. Well, thank you so much, Jess. That was a lot of fun.
My pleasure.
A lot of fun and a lot of depression.
Yeah. I love DRMs. See you in 2 weeks.
All right, bye.
Bye. You can contact us and find show notes on our website, randomlytyped.com.
The intro music is by Vansky.
Thank you, Vansky.
And thank you, listener, for indulging us.